Hi, I'm Mr. Spohn, and I'm bringing you a video on polyatomic ions. And we're going to learn what polyatomic ions are and how to write their chemical formula. And this video assumes you have some experience with naming ions, writing ionic compounds, writing the formulas and naming transition metals and things of that nature. So we're going to build upon that and move forward. Monatomic ions, well, mono means one, the prefix mono, and thus monatomic ions are single atom ions. And if we look down here, we have a bunch of monatomic ions. Sodium, iron 3, chloride, oxide. So anions and cations are monatomic ions. Whenever an ion, an atom with a plus or minus charge, whenever you have an atom that gains or loses electrons, it becomes a monatomic ion. It has a plus or a minus charge. And these ionic these ions, cations and anions, they combine together to form ionic compounds. And they do so in a ratio where all the net charge equals 0. And we're going to use this principle when dealing with polyatomic ions as well. Polyatomic ions, the prefix poly means many, so they are ions composed of more than one type of atom. And we can represent polyatomic ions as single units when writing chemical formulas. So what we're saying is if oxygen and hydrogen combine and in a ratio of 1 to 1, one oxygen and one hydrogen, in order to do so, it would have to have a -1 charge. And what that means is in order for oxygen and hydrogen to combine this way, it would have to gain a free electron. And this, we call this polyatomic ion hydroxide. Realize this is not an ionic compound in the sense of a metal and a non-metal joining. This is actually going to be a covalent bond, as are all of these. All of these polyatomic ions consist of non-metals bonding, gaining or losing electrons to do so. So these are all going to be covalent bonds. But the entire compound itself, or molecule rather, is going to be an ion of some form. In order for oxygen to combine with hydrogen, it has to have a -1 charge. That is called hydroxide, and this is a -1 anion. The carbonate anion has a -2 charge. So this whole molecule, the combination of 3 oxygen atoms and 1 carbon atom bonded together covalently, will form an ion because it has to gain 2 electrons to do so. And ammonium is going to be one of the few cations that we look at, and it has a +1 charge. And the sulfide ion has a -2 charge. So we're just going to look at writing chemical formulas with these and see how they go. So let's look at sodium hydroxide. If we had a chemical called sodium hydroxide, and this is an ionic compound, sodium has a +1 charge. It's in column 1A of the periodic table. It loses 1 electron. Hydroxide has a -1 charge, and we have this fancy chart. We don't have to memorize polyatomic ions. We usually are given a chart for them. And sodium and hydroxide will combine in a 1-to-1 ratio. Why? Because if I circle it, all the charge inside balances to 0. And what if we had something like calcium phosphate? Well, calcium has a +2 charge, and the phosphate ion, right here we see it has a -3 charge. And we could, of course, look this up on our chart. Phosphate is PO4 with a 3- charge. So in what ratio would these have to combine in order for all the net charge inside to equal 0? They certainly don't now. Right now we have a -1. A +2 and a -3 is a -1. Well, if we had 3 calcium ions, the total charge there would be +6. And if we had 2 phosphate ions, we would have a -6. And the net charge inside would equal 0. So we would write calcium phosphate like this: Ca3 PO4 and 2. And we need the 2 over here because the 2 is applying to everything in the parentheses here. It's saying that we have 2 phosphate compounds, or molecules. So we have calcium combining with phosphate in a ratio of 3 to 2, so that way the net charge inside is 0. And let's look at ammonium chloride. What is the charge on ammonium? Well, the charge on ammonium is +1. And the charge on chloride, and you should know that chlorine is in column 7A, so the chloride anion basically gains 1 electron. It has a -1 charge. So these should combine in a 1-to-1 ratio because there's a +1 and a -1. And that's exactly what happens. Ammonium, which is NH4, and chloride, which is Cl-1, combine in a 1-to-1 ratio. So we write that as NH4Cl. We have 1 NH4 and 1 Cl bonding together electrostatically. Now what about calcium hydroxide? Calcium is in column 2A, so it forms a +2 charge, or a 2 plus. And hydroxide, we can look up. Hydroxide has a -1 charge. So you should already see that you're going to need 1 calcium and 2 hydroxide to balance the charges out. So that way when you circle these atoms, you get a net charge of 0. Or these ions, I should say. And that's exactly what we need. We need 1 calcium bonded to 2 hydroxides. And we would write this as, not as that. This is going to be CaOH2. Get rid of this altogether. That 4 should not be there. But this is calcium hydroxide, CaOH2. There's 2 hydroxide, so we put the 2 down here after the parentheses, subscripted. And there's a brief assignment, and I do have this chart on the following page of the PowerPoint, so if you want to access it, you know where to find it. Analyze common polyatomic ions. What is the general difference between 8 and 8 ions? So kind of use these. Nitrate, nitrite, sulfate, sulfite, bisulfate, bisulfite, and these. What's the difference between an 8 and an 8 in general? Look at them. Write the chemical formula for the following ionic compounds. So there's 5 of them. What is the chemical formula? And what ratio will they combine? Use their charges to figure that out. And then I want you to name these ionic compounds. Go from the formula to the actual written name. And that's your assignment. Hopefully you have an understanding of polyatomic ions. They are just like regular ions in terms of writing formulas and chemical equations. This is Mr. Sapone. I'm out.